All right, so if we have a unit vector and theta is the angle from the positive x-axis to you, this is what we have. Let's look at the picture first. So this is our vector, and then theta is measured our standard position. Okay, so that means if you want to find, remember this triangle has a side of x and a height of y because it goes up to this point, xy. Okay, sorry about that. So that's what this means. So if you wanted to find the cosine of theta, cosine would be adjacent over hypotenuse. So your x is cosine theta, and sine theta is y over 1, opposite over hypotenuse. Okay, so we can replace, oh, that was supposed to be a pencil. I'm losing it here. X is the same thing as cosine theta, y is the same thing as sine theta. Okay, and then we can also write this in our linear combination form that we talked about yesterday, that we have cosine theta I plus sine theta j. And we call theta the directional angle. So this is just another way that we can write vectors. The power of doing this is we can do a lot of calculations on vectors because we can introduce all of our trig stuff. Yay, all of our trig stuff. Okay, so that's the reason we would want to rewrite it. So if you have a vector AB, which we can rewrite as AI plus BJ, if we want to find the tangent of theta, okay, remember tangent is sine over cosine, which is the same thing as the magnitude of the magnitude of V sine over the magnitude of V cosine, which is just going to be B over A. So, I know that's a little bit confusing. When we draw a picture, it'll be a lot better. But what I want you to remember this is tangent of your directional angle is B over A, okay? So if you have a vector, AB, the tangent of the directional angle is B over A. It's going to become super powerful. This is a super important thing to remember. Okay, so let me actually show you what that says. So we've got this vector, negative 6i, 6j, 2, 3, 4, 5, 6. So here's our horizontal component, 2, 3, 4, 5, 6. Vertical component. Okay, so this is what that vector looks like. Okay, if we want to find the directional angle, this theta here, we can just draw a triangle. Okay, the side is negative 6, and this is 6. Okay, remember this is your A and your B. Now, if we want to find that angle, well, obviously we have to find this angle. We're going to say the tangent of that angle is opposite over adjacent, so 6 over negative 6. But notice that's from here, 6 and negative 6. So what we have just used is tangent of theta is B over A. You see that those are the same thing? Tangent of theta is B over A, tangent of theta is 6 over negative 6. You can always, always, always draw a picture so that you can see it better. But this is just kind of a shortcut formula to help you remember. So we have tangent theta is negative 1. Hopefully you can see from this picture this has to be a 45-degree angle. But that's not the theta we want. We want our theta to be measured from here. So we're going to say that theta is 135 degrees. Okay. Let me show you another one of how this would work. So we have a vector, negative 7, negative 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, we want to find the directional angle, so we need this angle here. So you can always draw this triangle and figure it out that way. But what you're going to find out, let's see, negative 7, negative 4, is that tangent of theta is B over A. So negative 4 over negative 7, which is the same thing you get from the triangle. Okay, so tangent of theta is 4/7. Now, this is not one of our special triangles. We can't figure this out, so we're going to actually put this in the calculator. Make sure you're in degree mode. You're going to do inverse tangent of 4/7. And we get 29. Okay, that is not our answer. Okay, take a look at what's happening here. 29.7 is this angle right here. Okay. So if we want the entire angle, we're going to have to add 180 to that. So you need to draw the picture, think through what it's asking, because the calculator may not tell you the right coordinate. May not tell you the right quadrants for your angle. So we add 180 to this. Our directional angle is actually 209.7 degrees. Okay. We will talk about more applications of this in the next video. This little picture here shows you the cross section of an airplane wing. Hopefully you know how airplanes fly. It's like the air moves faster on top than it does on top of the wing than on the bottom of the wing, and so that causes the speed of the air on the top of the wing is faster, and that causes it to push up from the bottom. So these are just vectors kind of showing that. Anyway, more applications on the next video.